Hello and good evening, CSI135 Section 400 students for the Fall 2013 semester at Anne Arundel Community College. Over here on the right-hand side of the screen, you'll see that we've got lab number 7 displayed here, and this was from a little over a week ago. And we're going to go ahead, this will be the solution set for lab number 7. So the first one asks you, what is the IPv4 address for berkeley.edu? And again, you could use the NSLOOKUP utility on berkeley.edu, and that would be your answer, 169.229.216.200. What is the phone number I should call to reach the administrative contact for the berkeley.edu domain? If you use the whois utility on berkeley.edu and we're looking for the administrative contact, that is the phone number that you should use right there. 510-642-0866. On what month, day, and year was the berkeley.edu domain activated? And let's take a look and see if it's in here, and sure enough it is. Back in 1985 was when this domain record was activated. 24 April 1985. What is the default gateway address on the class system Vader? And we know that we've already looked at this. It's the PIX firewall. And so if I were to type ARP space -A, and this should not work, I don't believe, right? So because it's in the sbin directory, right? So I'll do sbin slash /ARP-A. And you can see we talked about the PIX firewall, and typically the default gateway will be the .1 address. And so we knew that the PIX firewall was the default gateway, and that is 192.168.0.1. Okay, on the class system Vader, what port does BGP run? And we had taken a quick look at the etc services file, services, and I'm going to go ahead and grep for, we're looking for BGP. Oh, sorry, got that backwards there, BGP. All right, so BGP runs on port number 179, and that's the Border Gateway Protocol. And then it wanted to know about NTP, so you could grep NTP, and you'll see here there's NTP. It's on port number 123, right? And that is your network time protocol. All right, what are the default ports for the following protocols? So what I'm going to do now is I'm going to cat etc services, and we'll pipe it through more, because again, remember the services file is going to list out all of the ports on the system. And remember, ports 1 through 1024 are reserved ports. So DNS, and again, you could have grepped, run this command and then grepped for certain things. So the domain name service, right, is port number 53. Telnet is port number 23. SSH is port number 22. IMAP is port number 143. We'd have to go down a little further to get to 143. And here we go. There's 143. So there's IMAP. And Kerberos is 88. So here's Kerberos. And FTP is 20 and 21. 20 for the control information and 21 for the data. Or I'm sorry, 21 for the data, 20 for the data, 21 for the control information. So there's 20 and 21. SMTP should be 25, and there is SMTP, port number 25. HTTP is going to be 80, and here's HTTP. And HTTPS is 443. Let's go a couple more. And there we go, HTTPS. So again, the etc services file keeps a list of all the ports. All right, so what is the IPv6 address for the host argus.stanford.edu? So if I did a whois on argus.stanford.edu, and let's see what it comes back with. Not much, so let's pull out that host name. And let's just type in stanford.edu. And let's see if it shows us Argus. It does. Argus.stanford.edu. And there is your IPv6 address. Right? Okay. What is the IPv6 address for the host avalon.stanford.edu. And again, you don't even need to run another command. There's the name, and there is your IPv6 address. Okay. Number 10, list 3 differences between IPv4 and IPv6 addresses. So some of the differences that we discussed are that the IPv4 addresses are already exhausted. They've all been allocated out. IPv6, they have not and probably never will be. The size of the IPv4 address is the IPv6 address is 128 bits. The IPv4 address is only 32 bits. And one final difference would be the notation representation. So the IPv4 addresses are a dotted decimal, right, like a 192.168, and the IPv6 addresses are in hexadecimal, and the fields are separated by colons. So those are a few of the differences. All right, write a bash shell script named alive.bash and place the script in the bin directory that resides in your home directory. So let me seed into my home directory. And have I created a bin directory? I certainly have. So we're going to call it alive.bash. Again, I want to put the magic number at the top to make sure it's the bash script that executes this script, bash shell that executes this script. All right, so I'm going to type in echo. What are we asking for here? The file should prompt the user for a fully qualified domain name or IP address and then execute the ping command to test to see if the host has network connectivity. So please enter in the fully qualified domain name or IP of the host you would like to check on. All right, and you'll notice we forgot the dash in at the beginning, so I'll scoot back here and we'll do dash in. All right, and so now I'm going to read in, and we'll just call it input. Okay, so now I'm going to issue the ping command on $input. So let's see if this works. And again, I always like to indicate where the end of that file is going to be. So, so we'll do a chmod u plus x on alive.bash. And now if I type in /alive.bash, it says please enter the fully qualified domain name or IP of the host you'd like to check on. And I'm going to try pix. All right, and there you go. So that's our default gateway, and I'm pinging it. So to kill it, I just do Control-C. So let's go outside the school domain, right? And remember, I don't have to type in the fully qualified domain name because the pix firewall is on the same subnet that I'm on, or that the Vader system is on. So what would we like to check? And how about Google. Pull that back. How about Google.com? All right, and there it goes. And you'll see I'm doing Control-C, right? Because it's going to ping constantly. So maybe let's see if we can change that. How about if I just wanted to see 5 pings? So let's take a look. We've got interval, flood ping, lots of options here. Quiet, numeric output only, the pattern, suppress loopback, packet size, timestamp. What else do we have? Verbose output, show version on exit, time to wait for a response. So we could do verbose output. Let's see what that looks like. So if I did a ping-v on google.com, right? Not much more information than we receive normally. If I just type in ping google.com. So we're not receiving much more information than normal. Let's go back up here, and I'm looking for numeric output only. And let's see. I can change the interval and -c count. So stop after sending count echo request packets. So with deadline option, ping waits for the count echo reply packets until the timeout expires. So we can use -c count if I only wanted to see 10 pings. So let's try that. So let me VI my script up again, alive.bash. And I'm going to come up here. We're going to do a ping-c, and let's say we only want it to ping 5 times. Sort of the default Windows behavior. So now I do /alive.bash. Let's check yahoo.com. Whoops. Control-U, yahoo.com. All right, so we should get 5 pings, and then that should be it. And there you have it. So we can make it act similar to the default Windows behavior. All right, so that was your script for number 11. Let me pull this down a little bit here. All right, number 12. How many hops is it from the class system Vader to google.com? And this is where you would use your trace route. And I'm going to trace route to google.com. And this could take a second or two to get going. All right, so we were able to get there in 9 hops. And it may have varied, but 9 hops for this attempt here. And who is the administrative contact for the unixunderground.com domain? So who is unixunderground.com? And it goes out to GoDaddy, and you can see that the administrative contact is myself because that's my domain. All right. Okay, number 14 lists 3 differences between TCP and UDP. So TCP is connection oriented. TCP establishes a 3-way handshake in order for that communication to take place. TCP is reliable, which means that there are checks to ensure that all of the packets have been received. UDP is unreliable. UDP is theoretically faster because of the unreliability. And both of them run at layer 4 of the OSI model. And the UDP packet size is smaller. That's another difference. Fewer fields in the UDP packet. All right. 15 lists 2 devices that run at layer 1. That would be a hub and a repeater. Number 16 lists 2 devices that run at layer 2. That would be a switch and a bridge. And number 17 lists 2 devices that run at layer 3. That would be a router and a multi-layer switch, which is oftentimes referred to as a router, but that would work here as well. We'll call it multi-layer switch. At what layer of the OSI model does TCP run? We just said it runs at layer 4. At what layer of the OSI model does IP run? IP runs at layer 3. At what layer of the OSI model does encryption take place? It takes place at the presentation layer, layer 6 of the OSI model. List the administrative contact for berkeley.edu, so I could do a whois on berkeley.edu. The administrative contact is the University of California at Berkeley, NOC. Right, and that's what NOC, Network Operations Center. All right, what file contains the DNS name servers for the class system vader.aacc.edu? And from your reading, it's etc resolve.conf. And there are the name servers that do our name resolution for the DNS service. Number 23, what IP address is used to represent the local host? So if I cat etc hosts, you can see here at the very top, localhost local domain is 127.0.0.1. And the key point of this address is that's the very first address that you should ping if you're having any kind of network anomalies or network challenges, because if you can't ping that address, which is the loopback address for the local host, right? If you can't ping that address, that means that there's a problem with the TCP/IP stack, and TCP/IP probably needs to be reinstalled, that you're having an issue on the local system. Okay. Who is the administrative contact for the harvard.edu domain? So it's who is harvard.edu. Right? Administrative contact is Jacques N. Laflamme. And what is the public IP for the domain unixunderground.com? So again, we'll use NSLookup, unixunderground.com. And it's 71.127.157.21. And this is a Class A address. Okay. Condense the following IPv6 addresses to their shortest form. And so what we're going to do here is I'll create a file and we'll just call it IPv6. So the first address, or actually let me go ahead and copy all of these addresses here, and we'll drop them in over here. Whoops. And let's see, we'll go like this. Okay, so in order to condense this address, remember we can remove extraneous zeros. So one way to do this would have been to pull in all of those zeros, right? Remember, you can only have 2 colons one time, right? So if there was another set of zeros here and here, I could not pull these back. especially since I've already done it here. Right? You can only do this once with the double colons. All right. Again, we've got a set where we've got some extra colons. Or, I'm sorry, extra zeros, so we can pull those back in. Right? I can also remove leading zeros like that. Now I cannot take the zeros out of the middle. Right? So these zeros here I cannot manipulate. Right? So we can remove extraneous zeros. Right? So I could have done that. And then same thing here. I can pull these in. Okay. And I could remove the leading zeros as such. Right? And we'll leave those guys there. We can pull them all the way back to 1. And the same thing here. Whoops, sorry, there we go. All right. So then here, I'm kind of stuck. I can only do that. And then here, and this is what I was talking about. So I've got a set of zeros here and here. So I can remove the zeros from either set of 8 zeros, but I can only do it in one of the 2 locations. So this time, let's do it here, right? And now I can take these guys down to 1 0, but I have to keep that 0 there, right? Cannot remove that 0 and this 0 and pull it in to make it 2 colons because I've already done that here. Okay, so I can clean those zeros up. Clean those zeros up. I can clean these zeros up here. Come back over here. Right? Okay. So that is your answer for number 25. All right. Number 26. Which of the following are valid IPv6 addresses? So this is clearly a valid IPv6 address, right? And typically what you're looking for is what you're going to see right here. The X's. Okay, so remember it's hexadecimal, and hexadecimal is numeric digits 0 through 9, and then alphabetic characters, always lowercase, and it is A through F. So anything past F in the alphabet is a clear indicator that it is not a valid address. So this is not valid. This IPv6 address here, yes, that is a valid address. This one here is not. And for this reason right here, ZZ and YY, those are not valid IPv6 designators. This address here is definitely valid. We'll come down here. This address is not valid. In fact, it's got the colon at the end and it's missing characters. And then finally, this address here is a valid IPv6 address. Number 27, how many bits are there in an IPv6 address? The answer is 128. And so 2 to the 128, if you remember correctly, is 340 trillion IP addresses. And the analogy that I have heard before that we talked about in class is you would be able to allocate, I want to say it was 1 million IP addresses to every single grain of sand on the planet Earth, and you would still have IPv6 addresses left over. So 340 trillion is a lot of addresses. All right, that is your lab solution set for lab number 7. Have a great weekend, and I will see you next week.